Okay, so good afternoon, class. So today we will be discussing example problem in the shear strength of the soil. Okay, so last meeting we discussed um, the formulas and the theories behind the shear strength of the soil. Okay, so we have laboratory setup and experimental setup to determine the shear strength of the soil. Okay, so if you recall, we have two different approach in solving for the shear stress of the soil. Okay, so we have two different approach in solving for the shear strength of the soil. Number one is by means of using the stress transformation equation. So this one is, if you recall your stresses in geotechnical engineering one, the Moore circle. So this one is all using the transformation equations. Okay, and number two is using the Moore circle or the graphical method. Okay, so let's try. So in example problem 1, the direct shear test, the soil was determined to have an angle of internal friction to be 31 degrees. Okay, and the cohesion of 26 kPa. If the normal stress is 150 kPa, determine the following. So I think na-discuss ko na sa inyo yung handout. So can you please open your handout? So handout 1 for the shear stress of the shear stress of the soil. Okay, so if we recall our handout, so open ko lang. Open ko lang yung handout natin. This one, share screen. There's problem in ano. Hindi nakikita yung ano. This one. Ito. So if you recall your handout 1 for the shear strength of the soil. Okay, so ito yung stress transformation equation natin. Okay, this one. And we have the direct shear test. So the direct shear test for normally consolidated or inorganic silt, your cohesion value 0. And for cohesive soil, you have the value of C. This one. So that is why in our problem, okay, nakikita nyo to, yung slides in full screen. Naglolo ko yung share screen ng ano ko ng Zoom. This one, kikita nyo ba to? Full view ng ano ng PowerPoint. Okay. So, we will determine the following. Number 1 is the total shear stress, and number 2, the force required to cause the failure in shear when the sample has a dimension of 50 by 50 and a height of 75 mm. Okay. So solving the shear stress of soil using the stress transformation equations. So we have a given data, let's say the sigma, the phi, which is the angle of friction, is 31 degrees. Your sigma n at failure to be 150 kPa, and your cohesion value to be 26 kPa. So the problem is a direct shear test. So this is your stress element. So we have a normal stress and a shear stress in our soil, acting on the soil. And since the problem is a cohesive soil, we have this Moore circle. So we are expecting to have a Moore circle na ganito. Okay, however, we will be using the stress transformation equations. So puro equations lang yung gagamitin natin sa pagsosolve. Okay, number 1 problem is determine the total shear stress or the shear stress at failure. So if you recall the formula for the slope of the line, so yung slope of the line na ito, this one, yung slope of the line of our Moore circle is also equals to the equation tau sub f is equals to C plus sigma tangent phi. Okay, this is the shear strength or the shear at failure plane is equals to the cohesion value plus the normal stress at failure multiplied by tangent of your phi, tangent of your internal friction. So, ang hinahanap natin is the shear stress at failure, which is tau sub F. So, alam natin yung cohesion value, alam natin yung normal stress, and alam natin yung phi. Therefore, we can solve for tau sub F. Okay? So, therefore, this is the equation of the line. So, direct substitution, we have 26 plus 150 tangent 31. Therefore, you get your shear stress at failure to be 116.129 kPa. Okay, so direct substitution lang siya using the stress transformation equations. Okay, then number 2, the force required to cause the failure when the sample is 50 by 50 by 75. Okay, so this is your dimensions of your direct shear box. So what if ito daw yung dimensions ng soil samples nyo? We have 50 by 50 by 75 mm samples. Okay, so by strength of materials, we can say that our force is equals to the stress times the area. So since we are talking about the shear area, the shear force, so therefore we need to find the shear area. Okay, so saan ba yung area dito na magkakaroon ng shear? So when the loads are applied dito and dito, so yung contact area for shear is this one. Ito yung contact area. So since shear box yan, so ito yung box. Okay, then this is the box. Okay, then magkakaroon ng tulak dito, force dito, and for dito. So mahahati siya dito. Okay, so therefore, we can say that our shearing area is the area na ito. This is the area at which your direct shear box causes failure. Okay, therefore, we can say that the force is equals to the shear force that causes failure. So it is equals to the shear stress in failure, it should be tau sub F, multiplied by the area in shear. Okay, so that is why you have this equation 116.13, which is 116.129. So divided by 1000 to be megapascal, multiplied by 50 by 50, you get 290.32 kilonewton. Okay, that is the answer for this problem. So the force required to cause failure. So another solution is using a Mohr circle or the graphical method to determine the shear stress of the soil. Okay, so again, we have the given problem, to which is angle phi, which is 31 degrees, the sigma n, which is 150 kPa, and the cohesion value to be 26 kPa. Okay, so the solution, since it is also a direct shear test, the same problem, we have this cohesive value, cohesive soil Mohr circle. So using this Mohr circle, this one, so ilalagay lang natin yung mga values ng given natin. So considering this figure, so alam natin yung value of x, value of your phi sub n. Okay, sorry, this one, the value of your phi sub n, which is 150. So since this is a direct shear, ito lang yung failure plane. This one is the failure plane. Okay, so that is why at this point, this is your phi sub sigma sub s, or the shear stress, and at this x coordinate is the normal stress at failure. Since may cohesion siya, so meron lang siyang tension or tensile dito sa soil nyo, dito sa may ends. So may mararamdaman siyang ganito due to cohesion. Okay, therefore, considering this triangle, we can say that our tangent phi, okay, is equals to this big triangle sigma s. So this is 90 degrees. Take note, this is 90 degrees. So sigma s, since tangent phi is opposite over adjacent sides, that is of opposite sides to be sigma s over adjacent sides, which is x, and sigma n, which is 150. Okay, then another triangle, we can consider this triangle, small triangle na to. Okay, kung nakikita niyo yung highlight, this one, yung small triangle na to, we consider that small triangle that is also equal to tangent phi, which is equals to cohesion o opposite sides over the adjacent side, which is x. Okay, therefore, we have this relationship, the tangent phi, which is equals to this equation and equals to this equation. So we are finding the first question is, what is the shear stress at failure? What is this one? Ano daw to? Okay, so given all the data, we have phi, we have sigma n, and we have cohesion value. So in order for us to solve for phi, sigma sub s, or the shear stress at failure, we need to find this value over here, yung c over x, and this also c over x. So kapag nahanap natin yung value of x, if you find the value of x, we can solve for shear the sigma s, or the shear stress at failure. Okay, therefore, using this relationship, tangent phi, which is c over x, which is equals to tangent 31, equals to 26 kPa over x. Solving for x, that is 43.27 kPa. Okay, so using this value of x and substitute natin siya dito sa ating relation, which is sigma s over x plus sigma n. So direct substitution, that is tangent 31 sigma s over 43.27 plus 150. Then cross multiply, we get sigma s to be 116.128, which is exactly the same by using the stress transformation equations. Okay, another problem, the force required to cause failure, since we get the same value of your shear sub x, the shear at failure, which is 116.128. Okay, you can solve for the same value of your force required, and you have the same value to be 290.32 kilonewtons. Okay, so do you have any questions, class? Okay, so direct shear test is the most easiest laboratory setup to determine the shear strength of the soil. Okay, so direct lang naman siya, so wala ka nang ibang iisipin. So you just need to find if your graph is cohesive soil, or normally consolidated, or sand, or your inorganic silt. So which is your cohesion value 0. Okay, so next problem is from Principles of Geotechnical Engineering. Okay, so by Das. Okay, the problem is a consolidated drain triaxial test was conducted on a normally consolidated clay. So the problem is during the triaxial test, the chamber confining pressure, or the chamber pressure, to be sigma 3, which is 276 kPa, and the deviator stress delta sigma d, which is 276 kPa. So if you check again your handout, the chamber pressure, sometimes called as sigma sub 3, that is the chamber confining pressure of your soil during the consolidated drain triaxial test. So that is the minor principal stress. Okay, so if you check your handout, so can you see this handout? Yeah, this one. So if you check your handout, we have different names for different notations. So for sigma 1, we have this one. So recall ko lang. We have the maximum principal stress, actual stress. Then for delta sigma, that is additional pressure, deviatoric stress, flanger stress. And for sigma 3, that is minimum principal stress, confining pressure, lateral pressure, radial stress, cell pressure, and chamber pressure. Okay? Okay, so since the given is 276 for the chamber confining pressure and the deviator's stress to be 276 kPa for delta sigma d. So the problem is asking what is the angle of friction. So the angle of friction is sigma phi. Okay, the angle theta that the failure plane makes with the principal major axis or the major principal plane. Letter C, what is the normal stress and shear stress on the failure plane? And letter D, what is the effective normal stress on the plane of maximum shear stress? Okay, so we have this solution again using the stress transformation equations. So we have the given data, which is the minor principal stress or the chamber pressure to be 276 kPa. Okay, you have your delta sigma d or the deviator stress to be 276 kPa. So take note, this is overly cohesive soil. Cohesive or over consolidated. Okay. So your problem is okay. Okay. Sorry. Your problem is a normal consolidated soil. So it should be normal consolidated. The problem is a normally consolidated soil. So therefore, your value of your C is equals to 0. Okay, so therefore, the equation of the line, so if you recall the equation of the line for the shear stress at failure, which is this one, the original equation of the line for the shear stress at failure is C plus tangent phi prime, sigma tangent phi prime. So since your soil is normally consolidated, the value of your C will be 0. Therefore, your cohesion value will be cancelled. And therefore your tau sub f will now be equals to tau sub f is equals to sigma tangent phi. Okay, then this is a triaxial shear test. We have this stress element. So take note that your major principal stress, which is sigma 1, is equals to sigma 3 plus your deviator stress. So therefore, your sigma 1 is equals to 276 plus your deviator stress to be 276. That is 552 kPa. This one. Okay, then from our derived equation last meeting, okay, so your sine phi prime is equals to AD over FA, the line AD over FA, which is also equals to the radius sigma 1 prime minus sigma 3 prime over 2 divided by FA, the line FA, which is C cotangent phi prime plus sigma 3 prime plus sigma 1 prime over 2. So since the cohesion value is 0 for normally consolidated soil, therefore our relationship from our derived equation will now be equals to this one. So maka-cancel out yung C cotangent phi prime since the value of your C is 0. Okay, therefore, the sine phi prime is only using this equation. Okay, so the problem is asking what is the what is the angle of shearing resistance or the angle of friction resistance, which is phi. So therefore, we can say that sine phi prime using this derived equation from our discussion which is sigma 1 minus sigma 3 over 2, which is 552 minus 276 over 2, divided by 552 plus 276 over 2. So, sauluhin nyo lang tong equations na to, this one. Okay, ito. So, just memorize this equation if you are given sigma 1, sigma 3, and their cohesion value in order for you to solve for phi. Okay? So, that is why you have your phi value to be 19.471 degrees. So, if you recall the relationship of your theta to phi, that is equivalent to theta, that is 45 plus phi over 2. Okay, so that is 45 plus 19.471 divided by 2. Therefore, your theta, this one, the angle theta or the angle of the failure plane and the major principal plane, that is theta, to be 54.736 degrees. Okay, so the question is letter C, normal stress and shear stress on the failure plane. So if you recall your handout, this one, okay, so we have this stress transformation equation given by the book. Okay, so kunwari this one, we have this stress element and we want to find the forces, the shear force at the failure plane. So you want to find the shear stress dito and dito. You need to transform this stress element. So itra-transform or i-rotate mo lang tong element na to. So to solve for that value, you need to use the stress transformation equation. Your sigma n or your normal stress at failure plane, which is this one. Ito, this one. Okay, so that is equivalent to sigma n equals to sigma y plus sigma x over 2 plus sigma y minus sigma x over 2 cosine 2 theta plus tau xy sine 2 theta. Then for laboratory setup, so in determining the shear strength of the soil, your tau xy is 0. Therefore, we have this equation over here. That is the sigma at failure plane, which is this equation. And the same for tau sub n. So since tau sub xy is 0, this is also 0, will become 0. Therefore, your tau at failure plane is given by this equation. So nawala lang yung equation na may tau xy. Nawala to and nawala ito. Okay? So going back to our problem. Okay? So the problem is normal and shear stress on the failure plane. So using that equation, okay, your sigma at failure plane is equals to this one. Okay, therefore, substitute natin yung values natin. We have 552 plus 276 divided by 2. Okay, plus 552 minus 276 divided by 2 multiplied by cosine 2 times 54.736. You get your sigma at failure plane or the normal stress at the failure plane on the failure plane is 367.998 kPa. Okay, then another equation for the shear stress at the failure plane. So using that equation, sigma 1 minus sigma 3 over 2 multiplied by sine 2 theta. Okay, so you have this equation or substitute natin yung values natin. We have 552 minus 276 divided by 2 multiplied by sine 2 times 54.736. You get your tau at failure plane to be 130.107 kPa. So direct substitution lang yung gagawin natin for the shear stress and normal stress at failure plane. So using the stress transformation equations. Okay, and another problem is determine the effective normal stress on the plane of maximum shear stress. So take note, class, that at any more circle, the maximum shear is at the radius 90 degrees. Hence, your theta in the stress element to be theta equals to 45 degrees. So given different more circles, so any more circles, so let's say ito. So saan ba nanggaling yung maximum shear stress na theta daw is 90 degrees. So given this Mohr circle, let's say ito yung Mohr circle natin. So cohesion value is 0. Okay, this one. Okay. Saan ba dito yung point na may maximum radius or maximum y value? Okay, so y value. So ito. Okay, this one. Okay? Saan ba dito may maximum y value? So, hindi naman tong point na to. Okay, hindi tong point na to. Ikot ka lang dito sa loob ng Mohr circle. Saan ba dyan yung magbibigay ng maximum y value? Tama ba na nandito at nandito? Kung itutuloy mo yung Mohr circle mo na to. Say this one. Circle. So, nandito. So, therefore, this is your tau max. Okay. Then, what is the angle of tau max from the major principal plane? So, ito yung major principal plane natin. Take note. Ito lagi yung major principal plane natin since nandito yung sigma 1. Okay? So, ano ba yung angle na yan? That is always 90 degrees. Okay? That is always 90 degrees. So, kung ibabalik natin siya sa stress element, so kung 90 degrees dito, that is 2 theta, dito ang mangyayari, magkakalahati, that is equals to 45 degrees. Okay? So that is why your theta in the stress element is 45 degrees. That is the point where you get the maximum shear stress. So using again the stress transformation equation, which is this one, okay, since tau sub xy is equals to 0, we can say that the normal effective normal stress and the plane of maximum shear stress is direct substitution lang ng equation na to. So using the theta to be 45 degrees. Okay, so theta to be 45 degrees, direct substitution, we have sigma at plane of the maximum shear stress, that is equals to 552 plus 276 divided by 2. That's 552 minus 276 divided by 2 cosine 2 times 45. Okay, that is equals to 414 kPa. Okay, so that is the value of this one. Point na to. Your tau max or the normal, maximum shear stress. Okay, so yan yung tau max. Ito yung hinahanap natin na sa sigma. Okay, sigma yan yung hinahanap nating sigma. The sigma at tau max. Okay, that is 414 kPa. Okay, next approach is this one. So consolidating our answer in problem 2. So ito yung ating shear stress. So this is your shear stress in the failure plane or the tau sub f, and this one is your normal stress at failure plane or the sigma sub f. Okay, so this is your failure plane and this is your Mohr circle. So as you can see, your sigma 1 is at this point, your sigma 3 or the minor principal stress at this point, and the difference of their value, this one, is your deviator stress delta sigma b. Okay, so another solution using the Mohr circle or the graphical method. So kunin lang ulit natin yung given. So according to the problem, your sigma 3 or the chamber confining pressure to be 276. So ipo-plot mo lang siya sa graph. Okay? Then another one is the deviator stress. So sabi sa deviator stress, that is 276 kPa. So you all know that sigma 1 is equals to sigma 3 plus delta sigma d, which is the major principal stress. So alam nyo na nandito na yung point ng sigma 1. Okay? Then, using again the Mohr circle, so plot nyo lang yung Mohr circle na ganito. So, dapat ganito yung pagkaka-plot nyo. Ganito. Okay, so perfect circle dapat siya. Then, since the problem is hindi nagbigay ng cohesion value or that is normally consolidated or soil, so ganito siya. So, yung point O natin is nandito sa 0. Okay, so since wala siyang cohesion. Then the angle or the angle nung ang line natin na to is the value phi. Okay? So therefore, we have this Mohr circle na to. Okay, then sulat na rin natin yung mga iba pa natin kailangan. So, kailangan natin yung center and the point of tangency. So, ito siya. We have the center of the Mohr circle and the point of tangency B. Okay. Then, sulat na rin natin yung value for the delta sigma D. So, since the delta sigma D is 276, therefore, the radius is equals to 1/2 of your delta sigma D. That is the radius of your Mohr circle. So that is 276 divided 2, that is 138. Okay, so this is 138 and this is 138. So therefore, your delta, your sigma 1, which is 552, comes from 276 plus delta sigma D, which is 276 din. So that is 552 kPa. So yan lang yung ating given. So pwede na nating ma-solve yung problem natin. Okay. So the problem 1 is find phi. Okay, find the angle phi. So I draw a line dito. So from the major principal plane and the failure plane, that is 2 theta, and you have this value r, which is the radius of your Mohr circle. Okay, so using that using this triangle, ito. So since that is a point of tangency, so therefore we can say that this one is always 90 degrees, di ba? 90 degrees yan during our discussion. So therefore, your sine phi, which is the sine is opposite over adjacent, which is the sine theta, the opposite side over adjacent, sine over, should be hypothesis. Opposite over hypothesis, hypotenuse. Okay, so that is sine phi, which is r over 276 plus 138, or the value of your r. Okay, so therefore we have sine phi, which is 138 over 276 plus 138. You get your value of phi to be sine inverse of 138 over 276 plus 138. That is equivalent to 19.471, which is exactly the same using the stress transformation equations. Okay, then problem 2, find the theta or the angle of the failure plane to the major principal plane. So we also know the relationship of theta and phi, that is 45 plus phi over 2. So direct substitution, we can get the value of theta to be 45 plus 19.471 divided by 2, which is equals to 54.736 degrees. Okay. Then next problem is find the normal and shear stress on the failure plane. So alam natin, class, na ito yung ating failure plane, this one. Yung line at the center to point of tangency B. So ito yung ating failure plane. So ang hinahanap niya lang is the normal and shear stress at that failure plane. So basically, ang hinahanap ng problem is what is the coordinate of your point B in the Mohr circle. Okay, saan lang, ano lang yung coordinate nito? What is the x and y value? Your x value is corresponds to normal stress at failure plane, and your y value corresponds to the shear stress on failure plane. Okay, so how are we going to find the coordinate of point B? Okay, so paano lang natin siya mahanap? So, alam natin na this is the radius and this one is the line phi. So, dito natin nakuha yung relationship na theta is equals to 45 plus phi over 2. Okay, so since this is phi, okay, this is phi. So, drawing another line dito. So, kung ito ay phi, this is also angle phi. Okay? So, therefore, we can consider this triangle na to to determine the coordinate at point B. So, paano yon? So, alam natin na this one is 90 degrees. This one is 90 degrees. Okay? So, paano natin malalaman yan? So, alam natin ang location na to mula dun sa point O is 276 plus 138. So in order to find the coordinate or the x coordinate of this point B, so kailangan nating malaman yung distance na to, the x distance nito. So the x distance is, ayan yung ima-minus natin sa 276 plus 138 to get the normal stress of point B or the normal stress at the failure plane. Okay, so paano natin ma-solve yung value of that x? Okay, so to solve for that value of x, we can use this triangle, itong triangle na to. Okay, if we use that triangle, so sine phi is opposite over hypotenuse r, which is equals to this equation. Sine phi is equals to x over r. Therefore, our value of x is r sine phi, which is equals to the value of r, the radius of the Mohr circle is 138 sine of your 19.471, that is 46 kPa. So 46 kPa this length, okay, itong length na to. So therefore, yung point B, yung normal stress at point B is equals to 276 plus 138 minus 46, you get 368 kPa. Okay, which is exactly the same then using the stress transformation equation. Okay, next problem is tau. Okay, the value tau, this one, itong value na to. Okay. So using again this triangle, this one, itong triangle na to. So since that is right triangle, we can use SOHCAHTOA. So cosine theta or cosine phi, which is equals to adjacent side divided by the hypotenuse r. So therefore, your tau is r cosine phi. So that is 138 cosine phi. That is 130.108. So this one, ito yung triangle na yun. So kaya nakuha natin yung tau to be 130.108. So that is also equals to the tau given by the stress transformation equations. Okay, then next problem is effective normal stress on the plane of maximum shear stress. So the same concept, we just need to find the x coordinate of this maximum shear stress na plane. So ito yung location of your maximum shear stress na plane, ito siya. 'Di ba? Ito yung location at which your maximum shear stress. Ayan, this one. So therefore, hahanapin mo lang yung x coordinate ng point na to. So basically that is equivalent to 276 plus 128. So you get this equation, this length na to. So that is the x coordinate of that point. Okay, itong point na to. Okay, so this is the point of the maximum shear stress, and the normal stress at that maximum shear stress is equals to 276 plus 138. That is also equals to 414 kPa. Okay, so nasa sa inyo kung anong gusto nyong approach yung gawin sa problem. So using the stress transformation equation or using the Mohr circle or the graphical method. Okay, so there are pros and cons in both solutions. Okay, the pros and cons is depende kung ano yung problem. Okay, kung saan ka mas mabilis makakapag-solve. And syempre, using the stress transformation equation, you need to memorize all those formulas. Okay, however, in a graphical method, you just simply draw the Mohr circle of the triaxial or the direct shear test. You can now solve for the problem. Okay. So example problem 3 is a cohesive soil with an angle of shearing resistance to be 28 degrees and cohesion of 32 kPa. So the shear stress at failure is 64 kPa. The problem 1, determine the stress at the failure plane. Number 2, define the what is the confining pressure. And letter C, what is the maximum principal stress. Okay, so isa-isahin natin. So again, solving using the stress transformation equation. So our given value, which is phi to be 28 degrees, your cohesion to be 32 kPa, and tau sub F is 64 kPa. Okay, then the solution. So normal stress at failure plane. So the normal stress at failure plane, that is your problem A. This one, so this should be over consolidated. Okay, so this is for over consolidated clay since the problem is cohesive soil. So may error ako dito. So typographical error. So C value for over consolidated soil or for cohesive soil is greater than 0. So may value yung cohesion nila. Okay? So since the problem has phi to be 28 degrees, cohesion of 32 kPa, and tau sub F na 64 kPa. So using again the stress transformation equations, your equation of the line is tau sub F equals to C plus sigma tangent phi. So that is your equation of the line going for the Mohr circle, di ba? So that is how you can solve for the sigma F or the normal stress at failure plane. So using this equation, direct substitution, your tau sub F, which is 64, equals to 32 plus sigma tangent 28. You can solve for sigma, which is 60.183 kPa. Okay, then next problem is what is the confining pressure? So if you check your handout, confining pressure again is sigma 3 and the maximum principal stress is sigma 1. So we need to find sigma 3 and sigma 1. So we have three stress transformation equations that has the variable sigma 3 and sigma 1. We have this equation, we have this equation, and we have this equation. Okay? So yan yung tatlong equations natin. Okay, so we have two unknowns. Take note, we have two unknowns. We have sigma 3 and we have sigma 1. So in order for us to solve for two unknowns, we need at least two equations. So at least two equations, two unknowns, di ba? So we can use this equation sigma at failure plane, which has meron na tayo nito. Ito yung sigma at failure, which is nasolve natin sa letter A. And this one is given, tau sub failure plane. Okay, your theta, you can have your theta from the relationship of your phi and theta. This one meron ka rin. So therefore, meron tayong sigma 1, sigma 3 unknown, sigma 1, sigma 3 unknown, sigma 1, sigma 3 unknown. So have two equations, two unknowns. So you can use this equation over here or pwede rin kunin nyo yung isa based on this equation sin phi prime, since meron din naman kayong value for sigma 1, for c cotangent phi and sin phi. So two equations to announce din. So any combinations of the three. So I am using this equation na nandito sa taas, which is sigma at failure plane and tau at failure plane. Okay? So the tau at failure plane, which is equals to sigma 1 minus sigma 3 over 2, which is sine 2 theta. So by direct substitution, we get 64. That is equals to sigma 1 prime minus sigma 3 prime over 2 sine 2 theta. So theta, we can now solve for theta. So ang theta lang naman natin is theta natin is 45 plus phi over 2, which is 45 plus 28 over 2. So 14, that is 59. Tama. Okay, that's 59 degrees. Okay, so using this equation, so cross multiply mo lang yung 2, this one. So using sigma 1, so cross multiply 2, you get 64 times 2 divided by sine 2 theta transpose sigma 3, you get this relationship for sigma 1. Therefore, your sigma 1 is equals to 64 times 2 over sine 2 theta plus sigma 3. Then substitute what we have in our problem. So sigma 1 equals to 64 times 2, what that is 128, divided by sine 2 theta, you can use 59 degrees, plus sigma 3 is equals to, so simplify mo lang to, that is 144.969 plus sigma 3. Okay? Then, using this relationship for sigma 1 and sigma 3, and direct substitute natin dito sa equation na to, this one, for the value of your sigma 3. Okay? So, we can now solve for sigma 1 from one equations, one unknown. Okay? So, ito. So, sigma 1, substitute mo lang yung sigma 1 in terms of sigma 3. That is 60.183 equals to 144.969 plus sigma 3 plus sigma 3 divided by 2, okay, plus 144.969 plus sigma 3 minus sigma 3 divided by 2 cosine 118 degrees. Okay, therefore, we can solve using your calculator and Casio 991 ES. Okay, so solving for sigma 3, you get sigma 3 to be 21.728 kPa. Okay, then using this value sigma 3 and substitute natin dito sa equation na sigma 1 equals to 144.969 plus sigma 3, you get your value of sigma 1 to be 144.969 plus 21.728, you get 166.697 kPa. Okay, so that is letter B and letter C in our problem 3. Okay, other solution using Mohr circle or the graphical method. So again, you have a cohesion in the soil. So ito yung graph niya. Ito yung Mohr circle niya. So compared natin to in problem 2 kanina. So yung kanina dito tayo nag-start since wala siyang cohesion value. Since ngayon may cohesion value, dito tayo mag-start. Then we have distance x dito sa likod. Okay? So unknown distance x. So draw nyo lang yung Mohr circle. Okay? Then establish all the points. So we have your phi, we have your sigma 3, we have your sigma 1. Okay? Then again, the tau sub f at failure, sabi niya dito, we have tau sub f at failure which is 64 kPa. So substitute na lang yung lahat. So ito yung point of tangency natin, yung point B. Then draw a line that is the your tau sub f, the distance tau sub f. So ito yung distance sa tau sub f na yan, this one. Okay, then since this one, we can now solve for the unknown sigma, this one. A question letter A is what is the normal stress at the failure plane? Or basically, what is the x coordinate of your point B? Okay, so we can consider again this triangle. Okay, yung triangle na to. So tangent phi, that is also equals to c over x. Itong small triangle na to, that is c over x. Then using this big triangle OBC. Okay, so that is tau sub f sine phi, that is opposite over tangent phi, that is opposite over adjacent sides. So that is 64 over x plus phi. Then considering small, that is c over x. Okay, opposite over adjacent sides. Okay, so we are going to find the value of your sigma. So katulad ng kanina, we need to solve for x. Then solve natin yung phi. So since tangent phi, makukuha natin to. Then ito c, meron na tayong value. Your value of tau sub f, which is 64, you have this value. So we have two unknowns. We have x and sigma. So in order for us to solve for sigma, so kailangan muna natin ma-solve yung value of x. Okay? So therefore, using the small triangle, tangent 28 is equals to 32 over x. So this is in degrees. Take note, this is in degrees. Okay, therefore your x is 32 over tangent 28. Okay, then substituting it to the big triangle OBC, so that is tangent 28, 64 over x plus sigma, which is 32 over tangent 28 plus sigma. So one equation, one unknown, you can solve for sigma, that is 60.19 kPa. So this is exactly the same using the stress transformation equations. Okay, next problem is to get for the value of r, to consider the triangle BAC in order for us to solve for sigma 3 and sigma 1. So we need to solve for sigma 3 and sigma 1. This one, the value of your sigma 3 and sigma 1. So para makuha mo yan, syempre, kailangan mo muna makuha yung r to consider the triangle BAC. So considering the triangle BAC, since alam natin yung value of your tau sub f to be this one, so makukuha natin yung value ng r. So the value of r is itong animation na to, this one. So ito yung r natin. So katulad kanina, that is angle phi, and this is 90 degrees. So considering triangle BAC or BCA, okay, then r should be dito. Okay, this one is your r. Okay, so cosine phi, since ang meron lang tayong adjacent side, so cosine phi, that is r, that is tau sub f over r. Okay, then solving for r, you get tau sub f over cosine phi. So which is exactly 64 over cosine 28, that is 72.48 kPa. Okay, then solve for the considering the triangle OBA. So considering the triangle OBA, okay, we can say that our sine phi, that is r over x plus sigma 3, okay, plus r. So para makuha natin directly yung value for your sigma 3. Okay, so paano ba natin kukunin yan? So pwede natin gawin, that is this triangle, this one, ito, and ito. So considering that triangle, we can use sine phi, that is r over x plus sigma 3 plus r. Okay, therefore we have sine 28. Okay, sine 28 equals to the value of r, the radius, which is 72.48 over 32 over tangent 28 plus sigma 3 plus the value of R. Then one equation, one unknown, you can get the value of sigma R to be 21.73 kPa. Okay? So, do you have any approach pa dito? So, pwede pa nating approach dito guys is since this is a graphical method, so we have different approach in order to solve for the problem. So, you can try, okay, you can try to find this location, itong location na to. Let's say this is value y. So you can get this value y by considering this triangle BCA. Then sigma plus y minus the radius r, okay, you can get the value sigma 3. So that is also another approach in solving for sigma 3. So since you now have the value for sigma 3, so the distance between the sigma 3 and sigma 1 is the diameter of the Mohr circle or twice the radius. Therefore, your sigma 1 is 21.73 plus twice the radius. That is 2 times 72.48. You get 166.69 kPa. Okay? So this is the length. This distance over here is twice the radius 2r. Okay, so do you have any questions, guys? Okay, wala naman. Okay, so moving forward to our problems. Okay, so this one. So for the practice problem, so this is homework 2. So duration is 1 week again. So for a dry sand soil direct shear test, it was performed using a vertical normal force with 10 kg and measured shear force to be 6.34 kilograms. So yung specimen natin was prepared in a circular shear box of 10 cm in diameter. So determine the angle of internal friction. Okay, what is the normal stress when 150 kPa is applied, and what will be the failure shear stress of the soil. Okay, then the next problem is when the normal stress is 150 kPa that is applied, what will be the failure force of the soil? Okay, number 2, in a consolidated drain triaxial test on a clay, so the specimen failed at the deviator stress, which is 124 kPa, and the effective stress at friction angle is known to be 31 degrees. So what was the effective confining pressure at failure? Okay, so next problem is consider the clay sample in problem 2. So consolidated undrained triaxial test was conducted on the of the same clay with the chamber confining pressure to be 1303 kPa. So the pore pressure at failure delta U sub dF is 33 kPa. What would be the major principal stress sigma 1 at failure? So this one is an example of CU test. So if you check your handout, the CU test is this one. So you have undrained samples, whereas your delta U sub dF is the difference of your sigma 1 and sigma 1 prime. And delta U sub dF is also equal to the difference of sigma 3 and sigma 3 prime, or the drain based on effective stress due to the presence of the pore water pressure. Okay, then number 4, a consolidated undrained test again was conducted on dense sand with a chamber confining pressure of 138 kPa. And the results showed that your sigma is 24 and your sigma your sigma prime is 24 and your sigma is 31. So determine the deviator stress and the pore water pressure at failure. So the delta DF is 293.1 and your delta U sub DF is negative 75.87 kPa. Okay, so additional readings is you can check this book Principles of Geotechnical Engineering, 8th edition using by Das and I think Das only, Braha M. Das. Okay, and for the reference of our manual, we have Das and Sivakugan. Okay, Fundamentals of Geotechnical Engineering and Introduction to Geotechnical Engineering by Kovacs. Okay, so do you have any questions, guys, before we end this meeting? Yes, okay. Any two methods is pwedeng gamitin. So, saan kayo mas comfortable? So, using the stress transformation equation or using the Moore circle. Okay. So, the cons of the Moore circle is you need to understand the geometry and the trigonometric identities. So to solve for the mga coordinates, yung mga coordinates. And the cons naman ng stress transformation equation is you need to memorize the equation and kung kailan mo sila gagamitin. So both merong pros and cons. So pinakita ko lang siya sa inyo since during the board exam, ang ginagamit is using the Moore circle. Since your mind is sobrang dami ng naka-store na data dyan. So mas madaling isolve yung problem using Moore circle na lang compared to the stress transformation equations. So maglalagay ka pa ng dadagdag ka pa ng sasaluhin na stress transformation equation. Okay, pero syempre yung stress transformation equation is direct substitution lang. So mas mabilis mo talaga siya makukuha during the board exam. So nasa sa inyo talaga yan kung anong gusto niyo. Okay, so ang tip ko lang sa inyo is identify the problem and determine what test, let's say CU test, CD test or UU test or unconfined compression test. So determine the problems, then identify all the givens and draw the Moore circles, okay? Then or using the stress transformation equation, and you can solve for the problem. Okay, so yung check nyo lang lagi yung handout na binigay ko sa inyo. Okay?